Hello, welcome back to Learn Physics. In today's topic, we are going to continue with our moving charges and magnetism. Okay, in last video we did tell about our Biot-Savart law, isn't it? In Biot-Savart law is used to find out the magnetic field at a particular point due to a current element, isn't it? Current is passing through a conductor which is having length L. If current is passing through a conductor having length L and I am considering a small portion dl over here and the magnetic field at the point P, this is the R, isn't it? This is the theta. Then dB equals mu 0 by 4 pi into I dl cross R by R cube. Like that we change, isn't it? So this is ideal sine theta R by R square. That one we changed it like this, isn't it? So in that I told you you can find out the similarities and dissimilarities between the electric field, electrostatic field and the magnetic field. Electrostatic field, how we determine about the electrostatic field? Yes, that forces, electrostatic forces equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square, isn't it? That is the electrostatic force field that we applied in Coulomb's law. Okay, so that force is 1 by 4 pi epsilon 0 Q1 Q2 by R square, isn't it? So if F12 if it is R12 then it is R12 square, or we can write this as mu 0 by 4 pi into I dl sine theta divided by R square. This one. If I am multiplying with R12 upward direction, this will become R12 cube in the vector form if I am representing, isn't it? So these are the two vectorial representations of magnetic field and electric field. So then what are the dissimilarities and similarities between them? First we are going to discuss about the similarities. Similarities between both the things. What you can find, what is the similarity which you are observing here? Yes, it is a long range force. It is inversely proportional to square, isn't it? Square of the distance between the point and the dl, isn't it? Magnetic field. In electric field also it is inversely proportional to the square of the distance between the two charges. So it is a long range force. It's of long range force between the magnetic forces. If we are considering the magnetic field or the electric field, both are of long range. And second one, if we want to find out the total field and what we should do, we can add all these magnetic fields, isn't it? So here also, while finding out the total force acting on a conductor, then we will be adding up all the force due to all the charges. That means it is obeying superposition principle. Okay, so the second one, it obeys the superposition principle. Okay, next third one is, see here what is the source for magnetic field? dl is the source of magnetic field. So it has a linear dependence. dB is proportional to L, isn't it? It has a linear dependence with the source. dB is proportional to dl. It has a linear dependence with the source. Here, what is the source for this electric field? That is linearly depending with the charge, isn't it? So it has a linear dependence. Linear dependence with the source. It has a linear dependence with the source. Okay, so that is the similarities between the electric field and magnetic field. Okay, so electric field F is equal to Q into E, isn't it? So if we can find out the same way, how we can find out the electric field and magnetic field. Okay, so now we are going to find out the dissimilarities. So next is dissimilarities. What are the dissimilarities that you are feeling over here? See here the linear dependence of the source I told, but that linear dependence with the source is this here source is the length of the conductor, isn't it? So it is a vector quantity. So in the case of magnetic field it is a vector source, but in the case of electric field it is scalar source. So Q is the source, isn't it? So it is a scalar source, and that is the first dissimilarity. And the second one, see there is an angle dependence for this magnetic field. Here no angle dependence. So angle dependence is there. Angle dependence only for magnetic field. In the case of magnetic field only there is an angle dependence. Okay, and then if I am considering the third one, whether any other things which you are feeling, yes, here as per Biot-Savart law, it is the perpendicular distance between sin theta is the, we will both should be perpendicular to each other. It is the dl sin theta is perpendicular dependence. It has a perpendicular to the direction, perpendicular distance, that only we are considering, isn't it? So it has the perpendicular component only we are considering, but in the case of electric field we are not considering the force is acting through the R2, isn't it? So the dependence is forces acting through the distance R1, but here R is acting perpendicular to DL. Okay, DL, therefore this here it has, say tangent is like this and R will be, so it will be the perpendicular component we will be considering the perpendicular component of DL to R. Okay, but here we will be considering the force which is acting through the R, isn't it? So that is so here in the case of magnetic field we are considering the perpendicular component, but in the case of electric field we will be considering force along R. We will be considering the force along R. Okay, clear now? So next is magnetic field at a point on the axis of a current carrying circular loop. So in a circular loop, if a point is there outside the circular loop and we are considering that a point is on the axis of a circular loop, a point we are considering. Okay, see this circular loop has current in it. Because of this current carrying circular loop, I am considering a point on its axis. What will be the magnetic field at that point? Okay, so if I am considering a circle like this, so suppose if I am considering a circular loop like this is my circular loop and current is passing through this circular loop, and I am considering on the axis. See, this is the axis of the circular loop. Here at the end of this point I am considering a point P. Then what will be the current magnetic field because of this current? Magnetic field at this point because of the current of this circular loop. That one we are going to find out. Okay. So here how we can draw that first? See, this is a circular loop which we are considering. Okay, then this is the center of the circular loop. See, I am considering a point on the axis here, P. Okay, it contains current is passing through the conductor. I am considering a small current element DL here. Through this current is passing. Okay, current is passing through this conductor. Okay, then what will be the magnetic field? If I is the current passing through the conductor, what will be the magnetic field at the point P because of this current element DL? Yes, as per Biot-Savart law, dB equals mu 0 by 4 pi into I dl sin theta divided by R square. So this is the distance R. Okay, so R square. This radius of the circular loop I am considering it as a, and this distance I am considering it as x. From the center of the circular loop it is at a distance x. Okay, so it is r square. Okay, so here r square, this triangle is a right angle triangle, so r equals root of a square plus x square. Okay, dl sine theta divided by r square. This is the formula. Now, here how we can find out the magnetic field here in this at this point? Because of dl, this will be, so what is theta here? What is the value of theta? See, here in the case of circular loop, while I am considering a circle, I am considering a current element like this, and what will be the direction of dl? Along the tangent. Okay, along the tangent the current will be acting, isn't it? So current is passing through this conductor, and this will be the tangent at this point, isn't it? If I am considering a point like this, so this is the point, from here I am considering a point. So what is the angle between these two? What is the angle? Yes, it is of 90 degree. See, the angle between dl and r, while you are seeing that, you won't feel it is 90 degree. You should consider it as a, yes, outside point. You can consider it practically like this. So this is the direction of dl. Okay, I am considering a point from here, and it is coming like this. Okay, from this point. So what is the angle between these two? Yes, dl and r, the angle is 90 degree. Okay, so you can clearly visible it is 90 degree. So what will be the angle here? I dl into sine 90 divided by r square. Okay, so db equals mu 0 by 4 pi into I dl divided by r square. Okay, now instead of this r square I can substitute this value, isn't it? So db equals mu 0 by 4 pi into I dl divided by, instead of r square I can substitute it as a square plus x square. Okay, mu 0 by 4 pi into I dl divided by a square plus x square. This is the magnetic field at this point because of this current carrying, magnetic field at this point because of the current carrying element, this dB. dl. Okay, so dB is like this. The same way we will be getting one more value from this side also, isn't it? And same way, so if I am considering a point here, the opposite side, same thing will be there, isn't it? Same element will be there. So what will be the total field in that conductor? How we can find out the total magnetic field due to the whole current element? Okay, so now we are going to find out what will be the total magnetic field. For finding out that one, we should consider what will be the direction of magnetic field, isn't it? So the direction of magnetic field will be, see, it will be dl cross r, isn't it? A cross b, what is the direction? A cross b will be both perpendicular to both a and b, isn't it? That a cross b equals ab sin theta into vector n, where vector n is the unit vector perpendicular to both a and b, isn't it? So if we are considering dl cross r, what will be the direction of dB there? dB will be perpendicular to both dl and r. So it will be, so dl and r are perpendicular. If x and y we are considering, what will be the direction of z then? Yes, perpendicular component like this, dB. Okay, if I am considering this as theta, what will be the angle? This is dB cos theta, and this will be dB sin theta, isn't it? And if I am considering an angle, same length dl, just opposite side, what will be the, yes, what will be dB direction? dB will be acting like this, the same value, isn't it? So what will be this angle? This will be dB cos theta, and this will be dB sin theta. So because of these two, what will be the total magnetic field? Yes, total magnetic field will be 2 dB sin theta. What we understood from this? So if we are considering the magnetic field at the half the portion, we will be getting the and then take the twice. Okay, then we will be getting the total magnetic field. And from here we understood that all the cos components are getting cancelled. dB cos theta and dB cos theta, since they are equal and opposite in direction, so they will get cancel each other. So dB cos theta will get cancelled, but dB sin theta will be adding up. So it will be 2 dB sin theta. Therefore we will get it as dB sin theta will be the total magnetic field at that portion, okay, including the direction. Okay, so here how we can find out the total magnetic field B? We can integrate that dB sin theta, integral dB sin theta. This is only for 1/2. Okay, so we are going to consider half of the portion. Okay, so instead of dB, what we can substitute? Mu 0 by 4 pi into I dl divided by a square plus x square into sin theta. What is sin theta here? See, if this is theta, this will be theta, and same way if I am considering here, this also will be theta. Tell me what is sin theta? Opposite side divided by hypotenuse. What is opposite side? Opposite side is A and hypotenuse is R. So sin theta equals A by R. Okay, so you will get it as integral mu 0. See, constants we can take it outside. Mu 0 by 4 pi I divided by a square plus x square. What is R? A square plus x square to the power 1 by 2. 1 by 2 plus this one, together we will get it as a square plus x square the whole power 3 by 2. You understood this? A square plus x square already it's here, isn't it? Then one more R. What is the value? A square plus x square the whole power 1 by 2. Now 1 by 2 plus 1 is 3 by 2. So we are getting it as a to the power a square plus x square the whole power 3 by 2. Now we are integrating the dl. What is the integral of dl? Integral from where to where we are integrating? From this point to just opposite point here. Isn't it? From here to here while we are integrating half of the portion. So what will be the total length? Yes, it will be pi r. 2 pi r is the total circumference. Here we are not considering the total. We are considering only half of the portion and taking the twice. Okay, so we will be getting the pi r there. Okay, so next portion I'll write it over here. Okay, this portion I am going to write it over here. So the magnetic field of the half the portion, while I am considering how much I will be getting, mu 0 by 4 pi into I divided by a square plus x square the whole power 3 by 2 into x square into a into r. What is 2 pi, the integral dl? What is integral dl? 2 pi a square, isn't it? 2 pi r is 2 pi, here what is the radius of the circle? A. So 2 pi a you will get. So the final answer is mu 0 by 4 pi into 2 pi I a square divided by a square plus x square the whole power 3 by 2. This is the final answer which you will be getting. Now we are going to consider the special cases. Special cases means if the point P is at the center and if the point P is very much far away from the center, what will be the magnetic field? Okay, so shall we do that? Now case 1. If the point P is at the center of the coil, at the center of circular coil. If the point P is at the center of the circular coil, how we will be getting? B equals mu 0 by 4 pi into 2 pi I a square divided by, see, x only vary. What is x there? Yes, see, from the center to the point P, this distance we took it as x. So now if the point P is here itself, what will be the value of x? 0. So you will get it as a square the whole power 3 by 2. You will get the answer as mu 0 by 4 pi into 2 pi IA square divided by A cube. So A square and A cube will get cancelled, 2 pi by IA, like that you will get. Okay, so this is the formula for the first one. Okay, then next is second case. If x is very much greater than A, comparing A, the radius of the circle, the speed is at very far away distance, then what we can do? We can, yes, B equals mu 0 by 4 pi into 2 pi I A square divided by A square plus x square the whole power 3 by 2. So if we are considering that one, what will be the value of B? Comparing x, A is very less. Then what will be the value of yes? X alone we can consider, because if we are adding 1000 to 0.1, then what is the use of adding the 0.1 to this, isn't it? So we can include x square the whole power 3 by 2. You will get it as mu 0 by 4 pi into 2 pi I A square divided by x cube. 2 and 2 will get cancelled, you will get it as x cube. What is this I A square? See, what is this pi A square? Pi r square is area, isn't it? Circumference, area of cross section is pi A square, pi r square. So mu 0 by 4 pi into 2 I A divided by x cube. If there are n number of turns in the coil, we can write it as mu 0 by 4 pi into 2 into n into I into A, that is x cube divided by x cube. This IA is called a magnetic dipole moment. Okay, so what is this IA? IA is called a magnetic dipole moment. So what will be the unit of IA? IA is ampere meter square is the unit. SI unit is ampere meter square. Magnetic dipole moment is I into A. If there are n number of turns of the coil, then what will be the magnetic dipole moment? N into IA. Okay, that is the unit of magnetic dipole moment. Okay, clear? So next is third one. If x is equal to A, what will happen? B equals mu 0 divided by 4 pi into 2 pi I A square divided by A square plus x square, isn't it? So A square plus A square the whole power 3 by 2. So you will get it as mu 0 by 4 pi into 2 pi I A square divided by 2 A square the whole power 3 by 2. Okay, so you will get it as mu 0 by 4 pi into 2 pi I A square 2 to the power 3 by 2 into A cube. This will get cancelled, you will get it like this, 2 to the power 3 by 2. Then this 2 you can take it downwards and you can rearrange this. Okay, so this will be this is so what is the point where the point we are considering, according to that the value will be changing. So if I am drawing a graph relating the magnetic field and the distance, so you will get a graph like this. Okay, as the distance increases, what will happen? It will be decreasing. Magnetic field maximum will be at the center of the circular loop. Okay, at the center of the circular loop, magnetic field will be maximum. Both the sides, it will be decreasing. Okay, clear all of you? So I hope all of you understood all those things. If you like the channel, please don't forget to subscribe. Thank you for watching. Bye.